Hello! This video is the first one of the SCADE Suite set of videos. It provides an introduction to SCADE Suite and its environment. I will explain the general context of embedded safety-critical applications, what model-based is, and what the SCADE language and SCADE Suite tools specificities are regarding these topics. Software is everywhere. However, you can find many different types of software, from video games to the software embedded in nuclear power plants. Embedded software is a software that is part of an electronic system, which can be connected to mechanical parts, as opposed to the software running on a general-purpose computer. Such embedded system is designed to perform one or a few dedicated functions, often with real-time computing constraints. Intuitively, a critical system is a system in which a failure can lead to a catastrophe. Think about the consequences that a software failure may have in a plane, a car, or a train. And all these domains are ruled by standards, which define precisely the criticality levels. SCADE is applied to real-time systems. These systems interact permanently with their environment, reading data and events, and producing actions to control the environment. A real-time application is a reactive application that follows the rhythm imposed by this environment. This defines the notion of cycle, external to the reactive application. The outputs of a reactive application are only determined by its inputs and their occurrences. The SCADE language belongs to the synchronous languages family and is a deterministic and declarative language. It is clear, unambiguous, and intuitive. The synchronous principle states that there is no delay between inputs reception and outputs production. While the code is being executed, its inputs do not vary. They only vary between two calls of the code. In other words, the reaction time must be smaller than the delay between two events. In practice, this means that each output is produced before the reception of the next input. Thus, internal processing time can be considered as null. This greatly simplifies the design of the application. There cannot be overlapping of data between cycles. So the outputs of a reactive deterministic application are only determined by its inputs and their occurrences. SCADE is the result of 30 years of research and development. It has been specifically designed to fulfill the safety-critical application development constraints. It focuses on the needs of such applications by offering a unique mix of data flow and control flow constructs, including state machines. In particular, SCADE does not contain constructs that are potentially unsafe, as unbounded loops or dynamic memory allocation. It has been used to develop numerous applications in avionics, turbo machines, industrial machinery, automotive, rail and transport, energy, and nuclear industries. The SCADE Suite tool is a model-based tool. SCADE means Safety Critical Application Development Environment. Model-based software engineering uses diagrams instead of code. The graphical representation of the application eases the understanding of the requirements, the functionality, and the design decisions. In SCADE, this graphical representation is strongly connected to the underlying formalized language. Model-based means more than just drawing models. It's a complete methodology, consisting of processes, practices, and tools. This process is supported by a software lifecycle. This enables the constant management of requirements with a fully integrated tool chain, ensuring code quality, safety, and maintenance. Automatic verification and simulation enable the detection of design flaws early when they are cheaper to fix. The SCADE Suite IDE is a model-based environment dedicated to the SCADE language. Its editor fully supports the SCADE language as it recognizes each language construct and its proper use. Within the SCADE Suite IDE, the user can edit and check SCADE models, perform traceability with requirements, perform model-based simulation and formal verification, perform model and code coverage, perform stack and time analysis, and finally, can generate code that will be embedded into the final system. The SCADE Suite Code Generator, KCG, ensures that the input model is correct with respect to the SCADE language syntax and semantics. It generates C or ADA code that fit safety-critical application constraints. KCG is deterministic. An output model always produces the same generated code with the same KCG options. SCADE Suite KCG has been developed following the safety standards. It is qualified and certified for the following standards: DO178B and C Level A, EN 50128 up to SIL 3-4, IEC 61508 up to SIL 3, with compliance for IEC 60880, ISO 26262 up to ASIL D. So this product is qualified at the highest level of safety across 5 market segments by 10 safety authorities worldwide. This code generator saves verification effort in the coding phase, such as code reviews and low-level testing on the SCADE Suite KCG generated code. As a summary, the SCADE Suite toolchain supports efficient model-based embedded software development from specification to code generation. Models are designed with a graphical notation understandable by any engineer. The notation relies on the formally defined SCADE language. Embeddable code is directly produced with the SCADE Suite KCG qualified and certified code generator. In the next video, you will discover more precisely all of the capabilities of the SCADE Suite tool. Thank you.